The first three talks are all focused on three large USDA grants that are currently going on. We heard Allison talk about BRD. Jared really did allude to what they're doing in the fertility project, and I'm going to wrap up that session with talking about what we're doing relative to selection for improved feed efficiency. So this is the team, and Jerry, this is the slide I always mess up relative to this talk. So Jerry's the project director for this large 5-year integrated USDA NEFA grant. I've revised it, and it's pretty darn close, but if you read through all the names and disagree with one, you've got to at least give me that. The point is that Jerry is the project director for this and heavily involved in the other two, and best I can tell, Jerry, what a project director does is make sure the other 16 are actually doing their job, which is a pretty big job in and of itself. The neat thing, as I mentioned, this is an integrated effort, which means in this case both research and extension. So not research that ends simply at publication, but research that ends in adoption or integration into our national cattle evaluations. This is a fairly staggering statistic. This is the amount of improvement that the poultry industry has made in feed efficiency since 1957, a 250% improvement. And if you just think about chickens the way they used to be and chickens the way they are today, you can visualize that, can't you? They don't look the same as the chickens that you used to go out and get on Sunday morning and bring in to mom to fry up. They're considerably different. And that's a testament to genetic selection. Unfortunately, in beef cattle, we haven't made near the improvement that has been made by other species in this trait complex. And in large part, I would argue, it's because we've left genetic selection or inherent variation between animals untapped. We haven't really put our foot on the gas and tried to genetically change this. The tricky thing, as with all these trait complexes, BRD, fertility, even feed efficiency, is simply defining what the trait is that we wish to actually improve. A lot of people think of feed efficiency as simply improving average daily gain. We all recognize the definition of that quite well. If you come from the feeding sector of our industry, you recognize it as either feed to gain or gain to feed. Feed intake, we can just think about it as dry matter intake, basically how much animal eats in a day, and we can collect this individually using GrowSafe systems, Kalen Gates, Instatech, which is here at the Meat Animal Research Center, so a lot of different systems whereby we can actually garner individual feed intake on animals. Or then the paradigm of residuals, and I use as an example here residual feed intake. And I know when people tell me that they're measuring residual feed intake on their animals, I know that they understand they misspoke. You don't measure residual feed intake. You don't measure residual average daily gain. We measure the components that go into it, and we calculate those things. Okay, so that's important to understand. Residual feed intake is simply what they ate deviated from what we expected them to eat based on their performance. Okay, and this, our prediction equation for feed intake, is really derived off of their cohorts. Okay, how their cohorts performed. Now, for those of you that actually put cattle through a feed intake system, that's important because cohort definition is extremely important. Okay, if I ran a bunch of Scottish Highlanders in there in the same contemporary group with a bunch of full-blood Keys, and I called them a contemporary group, and I used that then to calculate residual feed intake, I've made a mistake, right? Because then I'm using the full-blood Keys to tell me what the intake should have been on the Scottish Highlanders and vice versa. So contemporary group definition and the paradigm of residuals is extremely important. So what role does genetics play in whatever metric of feed intake or efficiency we want to use? I saw Merlin Nielsen in the back, one of his students, Kelsey Rolfe, Kelsey Luby now. Her master's work, actually using data from the Meat Animal Research Center, looked at some of these relationships, and we have average daily gain, dry matter intake, residual feed intake, and gain to feed. Heritabilities are on the diagonal, and genetic correlations are then on the off diagonal. And the take-home message here is all these measures are at least moderately heritable, meaning that regardless of what we choose, we can make genetic change. And I'm always sensitive to change versus progress. We can make genetic change in any of those traits should we wish to select on them. However, today we do have EPDs or selection tools for feed efficiency already. Residual average daily gain published by the American Angus Association. We have residual feed intake EPDs, dry matter intake EPDs, days to finish EPD. And I threw up here, it's really an index, Larry, but Red Angus's maintenance energy, really an index of mature weight and the maintenance component of lactation potential. But I throw it up here anyway as something that's more maternally focused. So we do have selection tools now, although these aren't as pervasive across breeds as what we might see in terms of selection tools for just weight traits or carcass traits. So there's a lot of room for improvement. And a question that I commonly get asked is, well, for a breed that publishes multiple of these, which do I use? They're not the same thing, and they are not necessarily going to lead you to the same animals. Okay, and that's an important thing to understand. So for a trait complex like feed efficiency, why would we be interested in a genomic approach? We know these traits are at least moderately heritable. The input, though, actually getting feed intake records and what you do with it afterwards really doesn't matter, but collecting that feed intake record is expensive. And actually collecting a phenotype can often be more expensive than actually paying for high-density genotypes. And I would argue right now, although there are some that would argue against this, we are ramping up our capacity to collect this kind of data, but still, I don't see in the near future where we're going to be able to collect the volume of data that we do for other traits. Okay, I just don't see that happening in the near future. That being said, phenotypes for all these trait complexes we've talked about so far are still absolutely critical. We still do have to have phenotypes coming in so that we can develop and later validate or evaluate, if you will, those genomic prediction equations. So I'll show you some relatively initial results from the project I mentioned earlier across 4 different populations. This is a Hereford population where data was collected actually here in Nebraska at Olson's, US Mark, a Simmental, really Sim Angus population, predominantly from the University of Illinois, legacy data, and then a purebred Angus population. This is the number of animals in each of those groups, and these are genomic heritability. So you can think about it as the proportion of phenotypic variation explained by the SNPs. And in 3 of these, the Hereford, the Simmental, and the Angus, they're all either genotyped with or imputed to 770K. The US Mark population was genotyped with the 50K. What I want you to, and this is for residual feed intake and dry matter intake, what we were able to do is basically recover what we would think is reasonably close to the full amount of genetic variation that we would expect for these traits with this density of SNP panels, and actually enables at least initial genomic prediction equations for these 4 breeds. A little bit more refinement. This is just looking at that Angus and Hereford population from the previous slide, the traits of dry matter intake and residual feed intake. This is the amount of genetic variation, the amount of residual variation, again, the genomic heritability. But what I want to point you to on this slide is the amount of genetic variance explained by the largest QTL. Think of this as the largest effect gene, if you will. And what you see for Angus, dry matter intake, the largest effect QTL explained just over 10% of the additive genetic differences between animals. And that may not mean a lot to you, but some of my molecular biology colleagues in the audience would love to find something like that. That's absolutely huge, okay, for a complex trait like dry matter intake. The other thing I'd point out, and I didn't put up any fancy Manhattan plots in this slide, I'm sure you guys have seen those before, colored up across the genome with dots representing SNPs. The fact is the largest effect QTL for Angus is not the same as the largest effect QTL for Hereford. Okay? Those are certainly different, and that just illustrates the point that these genomic predictions are not going to be portable across breeds. I know this is a bit hard to see. I stole this from Dorian Garrick, and in my opinion, it's probably the greatest slide Dorian's ever put together because it illustrates a point that I absolutely love to make. So imagine each one of these dots as being the average of a sire's progeny. And I basically plotted feed intake on weight gain. And what I want to illustrate from this is that depending on what I want to select for, those animals that are most efficient in terms of feed to gain, maybe those that are most productive in terms of average daily gain, maybe those that have the most desirable RFI, or what I'd argue, Dave, is I want to select for cattle that are most profitable. That would be my argument. Those would be over here. And although there is some intersect amongst those, they're not the same. Okay, they're not the same. And that's what we need to understand. And I would argue, at least from an industry perspective, we want to select on that which is economical. So I would argue for an economic index-based approach. And there are some examples of that now in our industry across a couple of different breeds where dry matter intake's been included into an economic index and serves as the input or the cost component of that index. And if you want to prove to yourself using your own cattle, if you have feed intake records on them, that all these different measurements don't lead you to necessarily the same decision, if you go to our project website, eBEEF.org, we have an online calculator there. You can basically include your information from a feed intake test and then rank them on a few different metrics of feed efficiency, one of those being an economic index as well, and you can see that you're not going to get the same rank. So it's important to realize that. Another common question that you as astute cattlemen always ask is, if I select for improved efficiency, whatever form that's in, what am I doing to the cow herd? Okay, what's that do to the traits that I really care about in terms of females? And I honestly don't mean to be facetious. But if we want to know that, collect, record, and let's estimate. If you want to know what the relationship is to dry matter intake and heifer pregnancy, for example, collect dry matter intake, collect heifer pregnancy, report them both to your breed association, and we can estimate that relationship. Okay? There's a lot of good experimentation, so what I consider smaller experimental research projects going on to look at some of these things, but at the end of the day, we need to know those genetic relationships in terms of national cattle evaluation. So the meeting you're at today is sponsored by the USDA project focused on genetic selection for improved feed efficiency in beef cattle. And part of that project includes what we still call the Weight Trait Project. Many of you in this room are involved in a group of producers and collaborating breed associations that began a partnership in 2009 to help us develop methodology for and later evaluate genomic predictors for a plethora of traits. And now we're focused on feed efficiency and feed intake. And these are the partners in that demonstration project from a breed association perspective. I wanted to point out the project website, again, beefefficiency.org. And in part I want to point it out because that's where today's talks and PDFs of the fact sheets or opinion sheets, depending on how you view them, will be posted after today's meeting. So you guys can go back, reread them, send the link to your friends and colleagues. So to begin to summarize this, at least in my opinion, we need to think about efficiency in terms of economic returns. And we've also heard talks earlier about BRD and fertility. I believe the same thing holds true there. An economic index approach is the most desired way to make change in multiple traits at the same time. Index values, though, true index values will require both inputs, so feed intake, and weights or output traits, presumably along with body composition. So a lot of our terminal indices right now, I think, are well positioned to include predictions for dry matter intake. Genomics could certainly play a large role here, although arguably we haven't completely brought this to fruition. And I would also argue that these large USDA grants serve as a jumping off point for our breed associations. If there is the pervasive thought that once these grants end, you can check that trait complex off your to-do list, that's an ignorant view. It's going to take a considerable amount of work afterwards to ensure that we still have not only standardized phenotypes coming in, but a lot of them, so that we can augment the genomic predictions that we started with these grants into traditional EBVs for those traits. So I hope Jerry would agree. We're hoping that the industry can leverage what we do in these projects, but at the end, we're going to have to pass the ball on to the industry to continue it. As I mentioned, an organized effort to collect phenotypes is critically needed, and Larry Keene, I think after our break, is going to talk about efforts of the Beef Improvement Federation in that regard. And I'd end by saying that selective phenotyping could be problematic. So if we think about me as a producer that has a grow-safe unit, and I collect the preponderance of feed intake data for my breed, that's not only problematic because now we don't have representation across the breadth of the breed, but also I'm likely not to spend the money feed intake testing an animal that I don't think has the potential of being a parent. So I'm likely going to make some primary selection and then only promote animals to feed intake that make that. And so then we have an issue with perhaps selective phenotyping. Presumably that's because the animal didn't gain well pre-test, but knowing me, I could have selected them for anything else.